Hello explorers and welcome to another video. Today I'm going to talk about looping concepts. So looping or iterations or force or something that goes through a bunch of data or mapping, filtering. There's a lot of different things that actually conceptually are some kind of a loop. And you have event loops in JavaScript and so on. So there's a lot of things in programming that is loops. And conceptually, a loop is where you, by design, need to do the same thing multiple times. And if you look back and look further down to the CPU, how this is accomplished is actually by jumping. So in the CPU you had some label somewhere. Let's say that you have some label called test at some memory position, and then you can do a jump to test. So that's a way to have some code here that does something and then have a jump statement after the code up to test again in order to do that again. And then you can have something called a conditional jump, where you actually jump to that position if and only if some condition is met. So that's how you write stuff in low-level CPU-based programming language. And one of those languages are Assemble. So assembly, you write code that goes right to the middle and just is translated to some bytes that the compiler can read. So we like abstractions, we like to lift ourselves up and do things a little bit more abstract. So in order to write looping concepts in Java, we have a few things that are very similar to what we saw down in the middle. So we have, for instance, a do function that we can say that we do something while a condition is true. So here we can say true, for instance. So this will do this over and over again until we break the program. So we do something here. If we do system out, print line, hello, this will print hello forever. You can just try to run this. This is one of the first basic programming that you do. You actually go through and makes it print something very simple. So here we say that we get a bunch of hellos. And you see here that I write do something while something is true. This means that the thing that I wanted to do here will be done at least once. So if I say that I will do something while things is false, I will get this print statement anyway. And you can have something conditional here, like while I is smaller than 4, we do an I equal to 0, for instance, and then while I plus plus. That will print this statement 4 times, because the first loop it was 0, then it became 1, and so on. But sometimes you want things to be done only if the condition is true. So you can say that I want to do this only if this while is true and not else. So in this case I will get 4 outputs, but if I change this to say that it should be larger than 4, then it will print nothing, because then I will do the condition before I actually enter my loop. So this is a way to do something for a bunch of times. But as you might know, when we are looping over these concepts, printing a while in order to print something 4 times, that's something that we can abstract out, and we can do an even more interesting concept. And what we have come up with in computer science is something we call for. And in this case, we can move these statements we had here into the actual looping concepts. So we say that we want some initial value that this while loop will start at. So that's 0. And then we have our condition that says that I should be less than 4. And then we have our iteration. So this will be done at the end of the for loop when everything else is done, in order to do this a bunch of times. So here we have our 4 output statements again. So that's a for loop in Java, and this is very commonly used for things that you need to do something over a bunch of data. For instance, let's say that I want to print this data array I have up here. I can say that I want to print it. I want the offset, in this case I, of the data up here, and I will get the 4 first numbers. So the first number is at offset 0 because it has nothing before it. So you point your pointer into memory and look for the in this memory position and set it by this value 0, so you get the first value, and then you offset it by 1 and you get the second value, and so on, in order to get this data. If you look at the list up here, you have similar functions, but they are more verbose. You can get a value at a specific offset, but they do similar things. And in this case, we see that I get an array out of bounds exception because I looked for the 4th element in my list and I only have 3. So that's a good way to know that you actually have gone past your bounds of your data structure. That will give you a very simple error message telling you that you either have a too small value or too large value to actually find something in your data structure. So people have used these for loops a lot, and many times you want to iterate over everything in your array, for instance. And then people have thought that maybe we can do this notation a bit simpler. So let's say that I want an int value. I can call it for d, as in data, and then I just print set a colon and data, and that will give me the opportunity to print everything in the data array and get them as int with a naming of d. So this will print the full array that I had up here of data, and it works as well with any collection. So let's say that I have strings instead here with my list, and you can use sets and everything that is called a collection. So all arrays, all collections can be used with this for concept. And if we take this even further, there's something in lists called an iterator. So let's do this list here and get this iterator. So what's an iterator then, and why should I use an iterator? An iterator on list does pretty much the same that we had in our for loop here. We go back to a while loop and we say that we want to do this iterator as long as it has a next value. And you can also say that this should be an iterator of strings. And that will help you in the next part here, because when you get a value from this iterator, you say I want the string of the iterator and I want the next value. And if you haven't specified earlier that the iterator is over strings, you will get an object back. So this will iterate over my strings and get them back. So why do I want to do an iteration then? Why do I want to iterate over a list? What is it that is nice with an iterator? An iterator goes only forward. That's a part of this. And one thing you can do with an iterator that you can't do with most of the other concepts is that you can actually simply remove things from your list. So let's say that we have an if statement here. We look at this string and we want to see if it ends with a K, for instance. And if it ends with a K, we'll remove it from our iterator. And if we, after we have ran this little function, look at our list. So let's do a system out println list. I wonder if I can do just like that. Probably not. Unsupported operation. This is my problem here. I can't do a remove on a list that I have created by as list, of course, because what is it that is specific with this new function as list is that it's immutable, so I'm not allowed to actually remove something from that. So let's create a new string, my new list, and create a new array list like that. And then we take my new list and add all of the list collection. So this is a little bit clunky, but just to prove my point here, if I do like this, then I'm able to remove things from my list. And here we see that I've gone through my data and looked at each element, and when I find something that ends in a K, I will remove it. And that's something that you can't do usually easily in a list and things during iteration. So if you use a for loop or a while loop, you're not allowed to change the data structure when you are working with it. You can do it with a for loop with offsets, but the problem there is that you need to keep track on when you remove an item that your offset should start one position earlier. So that's the good part by using iterators, that you can actually change your data while you're working with them. And in new Java versions, you also have the opportunity to take your list and create a stream of the list. And in a stream, you can do all the new fancy functions, like you can filter the stream, and here you will add a predicate with some function. Let's say that we will only return where A ends with, let's see, K, and if we have that function, we can then do a for each, and here we will again get A, and in this little function over here we can do a system out println A. So this will go through, filter out anything that ends with a K. So if this return statement is true, we will actually get a value back. And we can also make this much easier by just removing some of these concepts because they are one-liners. The same goes for this system out print line, and I think also the system says that you can actually remove these things and just use a static of print line in the end, and you will get the same result. So that's just a way to write the same little function in a much shorter semantic, so you don't have to write that much. So these are the different ways to iterate over something. There is one more concept in the stack here called enumeration. Enumerations is used in enterprise Java, and I haven't really found a really good reason why you should use those over other things, because enumerations has different namings than iterators, but they can pretty much do the same work. So I think iterators are easier, and they are present in both versions. So I would use iterators. And let's see here, we can also create a little map here. Let's say we have some strings. I created a small little map, as you see here, and there is some more interesting function that you can use in a map that could be actually good to know. If you want to do a for loop over a map, you can actually say that you want some strings. So let's say that I want the keys of the map. Then in the map there is a key set that you can go through and actually print. Let's do a system out print line key here. So that's a way to print all the keys in the in our little map over here. We can also do values, and that will print all the values in the map. But if you are using all the information in the map, let's say that you want to print a bunch of properties or anything that is saved in a map in some way, then it could be good to know that you can actually do a map entry of the same type as your different things in the map, and say here that we have an entry back, and then we get the entry set. And this will actually give you a tuple with both values, so you can actually print out get key here, we add an equal sign, and then we can get entry the value as well. So then we will get a list of all the keys and values and equal signs between them. So this could be good if you do a lot of data and so on. It's more efficient to actually get all the rows in your little entry here. So let's do a little program here. We have our data up here. We will go through each of these datas. So let's start here and get int with I data. So that's our iteration counter. We can say that we can call it counter. And then I want actually to find out how much space I need on each side of my little counter here. So space needed, and it should be 11 minus the count divided by 2. So this is my little space needed. Let's say that I want to loop through I equal to 0, I less than space needed, I plus plus. And here I want to system out, print a little space. Let's say that I want to do that afterwards as well. And in the middle I want to print my little count, like that. A little star over there, and let's see what that will give us. Of course, we need also to print out a little line break, or else this will be no fun. See if this will be better. And we have a little pine tree here, just by a very simple function where we figure out how much we need on each side. We have a little space needed here. We get our count and remove it from 11, which is the full width of our little tree here. We divide it by 2, so we know how much we need on the left side, on the right side. We do a for loop with the first left side. We do a for loop with the actual middle part of the tree, and then we do a for loop of the end right side. Probably not needed, actually. We can remove that part, and I think we will get a tree as well if we want this to be a little bit more efficient. And so this is how you can use looping concepts inside of each other in order to do 3D graphics, or you can do it to do accounting, do spreadsheets. You can do a lot with loops. And if you combine this with conditionals like if statement, case statements, and so on, you can do really intricate and really interesting applications. I hope that you learned something today. I hope that you found this interesting. And if you like this video, please give it a like, share it with your friends and colleagues, and if you haven't subscribed yet, please do that, and I really hope to see you in the next video.